right, welcome back everybody. It's time to do the now you try problem, walk through the solution here. This is for the basic function operations where we're plugging things into functions and adding things, multiplying things to the function. So let's take a look at this first problem. Given g of x equals negative 2 times parentheses 3x minus 1 close parentheses plus x, simplify the following expressions. The first one we're going to look at is g of x plus 4. So to do this, I'm going to take and I'm going to recognize that x plus 4 is being plugged in every time we see an x in the expression for g. So what we'll get here is that this equals negative 2 times 3 times, now there was an x in the original expression for g, so we'll replace that with x plus 4 and close our parentheses. Then we'll go minus 1 to continue our expression for g, and we go plus, and then there was an x in the original expression for g, so once again we replace this with the new input of x plus 4. Then we'll go ahead and simplify this. I'm going to keep the negative 2 for a second. Inside these main parentheses around the 3 times x plus 4 minus 1, I'm going to simplify in there first. So I'll get a 3x plus 12 minus 1 is plus 11. So I'm doing 2 steps of doing the 3 times 4 and subtracting the 1 to get that 11, just to save a little bit of time and energy here. And then plus x plus 4. Now we'll distribute the negative 2 across. So I'll get negative 6x minus 22 plus x plus 4. And then combine like terms. Honestly, if you want to challenge yourself, you could try and skip that step I just wrote. And we could get negative 5x minus 18. So to do that challenge there, I would say, okay, well, this is negative 6x plus an x is negative 5x. And then I would think I've got negative 2 times 11 is negative 22 plus 4 is negative 18 if I wanted to try and skip that in between step. If you're trying to challenge yourself, there's no need to do that, but it's something that is possible if you want to give it a go. All right, let's look at part B. We're done with that problem there. So let's look at part B. Here we have g of x plus 4. So this is saying take all of g of x, which is negative 2 times 3x minus 1 plus x. We're going to take that and we're going to add 4 to it. So I'm just going to take and tack on a plus 4 after the fact because the plus 4 is outside of those parentheses. And then all we need to do to simplify this is to distribute the negative 2. We get negative 6x plus 2 plus x plus 4, and then combine our like terms to get negative 5x plus 6. That's it for that one there. We'll go on to, I did that same thing as in the last video. This should be C. There we go. So this is g of negative 5x. So I'm going to take and start writing out the expression for g, negative 2 times 3 times. And then there was an x in the original expression, so I replaced that with the new input of negative 5x. Close parentheses, and then minus 1, and then plus there was an x in the original expression again, so I'll replace that with a negative 5x again. All right, so I've now plugged in the negative 5x for x, and now we want to simplify, so I'll say that this is negative 2 times negative 15x minus 1 inside the parentheses, and plus or minus 5x after the parentheses. I'll distribute the negative 2 across the first set of parentheses to get 30x plus 2, and then bring down the minus 5x. Finally, combine the 30x minus 5x to get 25x, and then bring down the plus 2. All right, part D. In this one, this is a lot more like part B, where we're doing something to the outside of g of x. So I have g of x times negative 5, but it's negative 5 times g of x, right? So, oops. I'm going to bring down the negative 5 and go times, and then I'm going to put in g of x. Actually, let's do the negative 5 like I did before. Negative 5 times, and then all of g of x in parentheses, negative 2 times 3x minus 1 in parentheses, and close the parentheses plus x, and then close the parentheses for all of g of x. We could do this in a couple of different orders. Let's keep the negative 5 on the outside for a second. We'll distribute the negative 2 across 3x minus 1 to get negative 6x plus 2, bring down the plus x, and then close the parentheses on g of x. We'll then bring down the negative 5 again and combine like terms inside to get negative 5x plus 2. And then I'll distribute the negative 5 across to get 25x minus 10. That's it. We've got all of part T complete. That's all the way simplified, so we're good to go there. Let's move on to problem 2, where we do a little bit more complicated thing here. This is giving us the function k of t equals negative 6x squared plus 2x minus 3. And we want to simplify 3 times k of negative 2t, close parentheses. So negative 2t is the new input for k. And then we're going to multiply all of that by 3. And then we want to add 13 to that. So plus 13 at the end. All right, so I'm going to do this with just saying, okay, what's k of negative 2t? All right, let's put that negative 2t in red. Let's see that insertion here a little bit easier. So I'm going to have negative 6 times negative 2t, close parentheses, squared. Oh yeah, so the original was negative 6x squared plus 2x minus 3. So I write k of negative 2t equals negative 6 times, and I had an x squared. So I replace the x with negative 2t in parentheses squared. I have to square all of that. And plus 2 times, there was an x in the original, so I replace it with negative 2t. Oh, I have another typo here, don't I? Let's take a look. This is going to take a second to fix. So I'm going to pause the video, fix this, and come right back. It's just going to be a quick thing. Actually, that wasn't nearly as tricky as I thought it was going to be. I just replaced, there was a typo there. That should have been an x as the input, replacing the x with negative 2t here. Make sure that that is adjusted in the mind map as well. Okay, I'll get back to that. Sorry about that. And, okay, where was I? Negative 6 times negative 2t in parentheses squared plus 2 times negative 2t in parentheses, and then minus 3. We're bringing that down from the original expression for k of x. And we've now replaced the x with negative 2t, and we'll simplify this. Bring down the negative 6, and then when I square negative 2t, this is going to be times 4t squared. And then plus 2 times negative 2t is minus 4t, and then bring down the minus 3. And then just negative 6 times 4 is negative 24t squared, minus 4t minus 3. And now we can't combine any more like terms, so we're all good there. Let's now go ahead and get the 3 times k of negative 2t. So this is going to be 3 times everything we just got for k of negative 2t. So that's what we just had, negative 24t squared minus 4t minus 3, all in parentheses. And then we just want to distribute the 3 across here. So we'll get negative 72t squared minus 12t minus 9. Let's just note that arithmetic. 3 times 24, 3 times 20 is 60. 3 times 4 is 12. Add those together to get 72. And then 3 times 4 is 12. 3 times 3 is 9. All right, now we have one more step here. we want to take 3 times k of negative 2t, and we want to add 13 to it. Let's do it in different colors. Go blue. Plus 13. I try and avoid red and green because that's the most common colorblind mix-up out there. So we'll take the 3 times k of negative 2t, which we just had, which is the negative 72t squared minus 12t minus 9. And we just want to tack on the plus 13 to the end of that here, because that plus 13 is outside and happens after the multiplication. So we'll simplify this down and get negative 72t squared minus 12t plus 4 after combining the negative 9 and plus 13. And that's it. That's completely simplified. All right, let's just take a look back here. And this is all of the answers to the Now You Try problems. Thanks again for watching, and in the next video we'll look at some applications of this so that we can get a little bit better feel for, why would we even be doing this kind of thing? I mean, other than just because we can mathematically, and it's interesting to explore the things that we can do mathematically, but with math, things go two ways. Sometimes you have like an application demands mathematics finds a way of looking at it in a good way. Other times math moves forward and starts exploring things about what it can do, and then we find applications for it after the fact. So in this set of videos, I wanted to kind of get into the math first, and now we'll say, okay, if we can do this with math, let's figure out how this actually applies to different kinds of scenarios. So we'll do that in the next video. Thanks again for watching, and we'll see you soon.